example that I'm going to present for you is BIM workflow for pre-construction constructability evaluation using 4D CAD. The idea behind this subject is that it's based on my experience in the construction site that I had before joining this program. I could notice that during the construction there are some hidden or unseen steps that actually are costing the optimization of constructability and quality of the BIM process during the construction. So what I'm presenting here is to promote those hidden steps, to be able to focusing on those gaps and optimize the application of BIM process during the construction. But the thing is, those steps, those hidden steps. So the idea is to have more control over the constructability of the project and during the pre-construction phase. What is the pre-construction phase? As it has been defined at the construction design and management regulations of UK, it's a phase that preparatory work and design is being handled between the design phase and construction phase, and often it can extend to the construction phase. So here I am actually defining the scope of my study. It's after the design phase and before it goes to the and it can continue during the construction phase. It is that from as planned to the as constructed phase. And what are we adding in between is actually analysis of those tasks that are being handled during the pre-construction, finding out the conflicts, or what I have done here is proposing a workflow that can anticipate those task conflicts and prioritizing them to prevent those conflicts between the tasks that are supposed to be handled during the construction. The keywords that we are using is constructability, BIM on site, activity model, impact clashes, pre-construction, and task files. Some of them have been proposed during this research study, and some of them have been borrowed from previous literature reviews. So what we are finding the solution for is that actually for example, one of the questions is that what are the deficiencies in the current 3D BIM model that can be addressed during the pre-construction phase. One of them is that, as you know, the 3D BIM model actually is a model of what is being designed, and then it can move towards the construction phase that is that gives us the as-built model. So during the construction, some minor changes can happen that affect the design of our model, and then we can change it to as-built model. But what is missing in the 3D BIM model is the tasks that handle each of these elements to be constructed, and the requirements of those tasks. We don't have them in 3D. We have them actually in 2D data in the project scheduling or planning. So here I am proposing a prototype based on BIM workflow that can actually visualize those tasks and their requirements, so they can alert the managers at every step of the construction. So the conflict can be prevented, or at least be minimized for optimization of the process. Sorry. I'm going to here. I'm going to present you the prototype that I developed this is what we're gonna have at the final stage at the Navis work. The softwares that I use for my prototype are the Autodesk package, actually Revit, Dynamo, and Navisworks, including Excel sheets that can be used by the ones that are not actually being experts. So we get data through Excel sheets from them, which are the foreman, project managers, and we input them to the Dynamo process. The prototype does what? I'm going to exemplify it for you because it's a real world problem. So I use the real world project as a case study, and with an example explanation, you can understand it easily. Imagine you have the 3D model of a project, and you are at a scope of work that at one side of your building project, you want to you have labor work to do the landscaping here for you. You have a scaffolding as a temporary facility in the site. You have window that needs to be installed on the facade, and you have facade louvers that have to be installed on it. But what is missing here is, okay, each of them are scheduled and planned perfectly, that, okay, at this day and this time, you have to address them, and you have to have people there and materials there to work on them for installation and everything. But what is missing here is that, for example, when you have the scaffold here, there is some safety space around it that needs to be considered, that safety space prevents the labor from landscaping part to work at some part of the landscape. So these two tasks will clash and will make delays, and each delay will will have wastage of cost of money, I mean, or material and time. So when we are considering the scaffolding of for the facade, we cannot just see the element of a scaffold. There is a clearance offset around this that we should consider. Also for landscaping, there is a clearance offset around it that should be considered for the loading and unloading of materials, for the people movement, for safety, and many other factors that these activities actually have clashes. But if you send this model to the Navisworks, you cannot see any clashes between the landscape and a scaffold and window and facade. But the activities around them will have. So now what I propose is to model those activities and space requirements around each of these elements, so we can consider them when we are planning and scheduling our construction project. Here, using the Dynamo, firstly, based on in Revit, we can isolate the parts that we are going to work on, let's say, in next 2 weeks. And then in Dynamo, we select these elements and we turn them into bounding boxes. And then a family that has been defined with our required parameters in the Revit is being replaced by those bounding boxes. And the distances that we see between the, for example, facade element with the bounding box, actually the clearance offset that is being input through the Excel sheet, from the Excel sheet through the Dynamo process. These offsets are actually coming from the experience of foremen or project managers that are handling the project. For example, they know that if they want to install a window on a facade, how much space do they need around it, how much clearance, how it's going to be transferred to that area. So those are the knowledge that we are gaining from our people and from previous projects that we have handled. So the space around that window actually gives us the real clearance that we need, and these boxes together will show us how much flashes of activities we have in our project, and we can rectify that, or we can prevent it if we are looking at it in advance. And this is in a small stage, it's just a prototype, but in a more complicated and bigger project, then these flashes can be imported to a Navis work system, and the flashes can be categorized, color coded, so it can easily be handled by the project manager to be prevented, or at least minimize the flashes, so the quality of the construction will be improved for sure. That was the whole thing that I proposed in my research study. Thank you.